We're going to answer this question before us. It says, solve the square root of 3 tan of theta plus 1 is equal to 0 for theta is an element of 0 to 3 pi. Okay, so what we're going to do first is we're going to rearrange this so that we have a trigonometric ratio as our subject. The next thing I'm going to do is I'm going to figure out my reference angle. So remember, the way in which you do that is you ignore your sign and you just look at 1 on the square root of 3 and you try to figure out what the reference angle is going to be from that. After a while, you'll be able to do this really well just because you've had enough practice, and you'll be able to identify that this is pi on 6. The way that I think about it, so this is kind of what's happening in my head now, is I'm picturing my unit circle here. There it is. Whoops, let's see if I can draw a better circle than that. And I know that 1 on the square root of 3 gives me the shallowest gradient, because I think of tan in terms of its gradient. So I know that I'm there, and that gives me the smallest angle, which is pi on 6. But remember, we now need to consider the negative here. So that means I'm actually going to be in my second and fourth quadrant. Now, hopefully you can appreciate that my unit circle here is atrocious. So that should look more symmetrical, but I exist in my second and my fourth quadrant. So now it's just a question of, all right, so what is pi on 6 in my second quadrant? It's 5 pi on 6. And what is pi on 6 in my fourth quadrant? It's going to be 11 pi on 6. But what you now need to appreciate is that we don't have all the necessary solutions here, because we have to go from 0 to 3 pi. So far, I've only considered 2 pi around. I actually now need to consider 3 pi, so pi more. So that actually means, if we can just think about it for a second, this is going to be one of my solutions, 5 pi on 6. This is going to be one of my solutions, 11 pi on 6. But then I can go around again and then end up back there. So that means I'm going to take 5 pi on 6 and I'm going to plus 2 pi onto it. That's going to be 12 pi on 6 plus 5 pi. There's going to be 17 pi on 6. So that is going to be my solution. 5 pi on 6, 11 pi on 6, 17 pi on 6. You have to keep your eye out for that domain there. That domain, even if you understand it, you can leave now, but just to break it down a bit more, if we picture a number line here, so here's 0, here's 2 pi, here's 3 pi. What we figured out is that, we have 5 pi on 6 here, we have 11 pi on 6 there, but I need to stop at 3 pi, so there's still one more here, and there was one at 17 pi on 6. So we still needed to account for that. My terrible drawing here probably doesn't help. But hopefully you can see there that I could go around 2 pi and then a bit more, and that still fits into the 3 pi domain. So that's my answer. Again, if you're struggling to get your head around the domain, make sure you come speak to us.